Welcome. Today, question number 40. Remember, today's class will be somewhat short class. Remember, short but very, very powerful, because you can see so many things are there. See, this frame, if you solve a method of joint, if you observe earlier how much explanation I have given, you can go back and see there. Okay, now, first I read the question. Little space problem is there. So what I am doing, that's why I am dictating the question. Find axial forces in members DC, DF and AF. You search later. Second one, DC, FC and FG. One more, CE, EG and GB by method of sections. Class, treat each question as independent question. Because someone will tell, sir, DC already over. Where over? If you are doing question 1, question 2 and 3 are not there. If you are doing question 2, 1 and 3 are not there. If you are doing 3, 1 and 2 are not there. At a time 1. So that, see, DC came there. Second time DC will come. Don't see that answer. This I told earlier. Treat independent questions. Okay. This is the frame. See, first I will tell you how is the arrangement. AB 333 meter. See, I forgot to write B here. I actually wrote B, later rubbed it for space problem. AB, okay. B is here. AB, see, 333, equal division. Then, from here, C, mark height of 3.5 meter, join here, you get this triangle. Then, from here, see, earlier one question we solved where this point you join to midpoint of AC. But remember, this time not midpoint. From here, draw perpendicular, you get this point, see, 90 degrees. Draw perpendicular, 90 degrees. So, this question involves lot of trigonometric part. Remember, okay. Now, 1 minute. Before I start, those who want to learn each and everything should listen to me and follow whatever I tell in the class, not half-hearted. Half-hearted people or lazy, they need not continue my class. This every class I will tell. Okay, see. First here, note, this question is already solved earlier by method of joints. So what? I only solved method of joints, where we found axial forces in all the members. Engineering mechanics, class number 331. Part 5. We are in part 5. Lecture 14, question number 17. Okay. So, go back to that question and write and understand everything up to and including calculation of support reaction. That's all. Why? Once you find support reaction, there we continued for method of joints. Here we will continue for method of section. So, the earlier class, question number 17, what all I told, everything you write once again. Good. That's how you learn, not by referring there. Don't write, refer that question. No. That is for lazy people. You should write it so that when you read this question later, you should not refer anything. Refer only this question. Okay. Now, and one more note I will tell you now. See, class. Class means I am telling. See, I told you up to and including calculation support reaction. Support reaction we found there. If I find today same person, same principle and same question, why should I do it? Go back, study and come back. Okay, now, class. For support, I am dictating. For finding support reaction, we did not put this sketch earlier. No. See, roller support VA, hinge support here, roller is left side, VB, HB, then forces. We did not put this sketch. Instead, we carried out some trigonometric calculation because, see, you required at that time what is this height for taking moment. Oh, that height I wrote here. What happened is, see, I write here now. What happened is, space problem, I slightly move the camera this side. So that height I don't know. I know it here. 1.4539. Okay. 1.4539 meter. Okay, if not visible, I am dictating. See, I'll tell once again. This height is 1.4539 meter. Okay. See, now right here. At that time I told this question involves some trigonometric calculation, important calculation. So, I told at that time, before you find support reaction, you should be ready for support reaction calculation. So, I did not write this sketch. I put only a triangle sketch with parts, no load, nothing. There, I first found out, see, what is this. See, if you remember, I don't know how I did it now. Maybe this length I found it. Using that length, I got projected what is this length. See, from here up to D, the horizontal, see, why you require it? See, 12 into this distance. So, from here to line of action of the 12, this distance, I got by trigonometry there 1.8693 meter. Then 6 into this height, that height I got 1.4539 meter. What is the height here? Same height here. What is this distance? Same distance here. So that is not a problem. So this all calculated there. See, this everything was calculated there. That's why I told, but this question you should carry out everything right up to support reactions. Now, then also I got this theta 1, theta 2, theta 3. See, and again, if it is theta 1, this is also theta 1, theta 2, theta 2, theta 3, theta 3. See, then I wrote this sketch for support reaction calculation. Now remember, this sketch is reference for method of section. This sketch, this all told, this right here, this sketch is our reference for method of sections. This sketch we are referring. Okay, then in that class, I took moment about B, VA into something, etc. I got VA plus 16.312. Sigma V0, I got VB 22.688. Sigma H0, I got HB minus 9. And I got theta 1, this angle, see here value, theta 2 here, theta 3 here. Remember, in this sketch, all red colored values I wrote, we got in question number 17. That is, what is this distance, what is this height? This height is already known. How much? 3.5 meters, see. Oh, that height I write somewhere. Here space problem is there. Okay, I will remove this one now. See, I should write that height also somewhere here. That height is 3.5 meter. Remember, this is 3.5 meter. You write here, this is our reference sketch for method of sections. You write here. Okay. We got this height for taking moment about this point. We got this distance. Whatever this distance is, same distance here also. Some name D dash I told. You want to learn, go back, study, not study. Write everything up to support reaction. Stop. Then come to this class. See, then right here. Come here. Come here. Okay. Now, we will start our question number 40, where we have to find forces. See, at a time, 3 members, 3 groups are there. All independent question. Okay, start. Calculation of. I forgot of. See, sometime I forget. Of. Okay. Axial forces. I don't like it. See, sometime heading, I don't want to spoil it. Okay. 1. What is there? 1. Calculation of axial forces. See how much respect I give to subject. You can see I call axial force. I don't call force. People call column load. No, column load is okay for understanding. Tell axial force for the column. People tell moment for the beam. No, wrong. Don't call moment. It is not correct. Bending moment, shearing force, twisting moment. That way you have to call, because that is called respect to subject. One small example I will give you. I have no time actually. I have a very good friend who is very strong in structural engineering. One day he called me and asked, I was in the office, what is the moment for that beam? I told 0. He knows. He told, okay boss, bending moment. Oh, then I told him, I took the software open, told 300 something, okay. Then he told, if I tell moment, you take bending moment. I will tell, no. If you tell moment, I will take moment only. Why can't you tell bending moment? Or tell BM? Okay. If you don't want to waste that much, instead of moment, see, BM. Okay, he told, okay, no problem. If he won't hear this class, I know. He will start laughing. He will tell, oh, you and your concept. I told, yes. I always stick to concept and give respect to subject. Okay, sorry, this is a joke only. Calculation of axial forces in members DC, DF and AF by method of sections. Okay. Now, consider section XX cutting above 3 members. Okay, start. Come here. Before cutting, see, this sketch required. Cut it here. Before that, okay, cut anywhere you like. Okay, I will cut somewhere center only, no problem. See, which members you want? See, this theta 2 is troubling me. Hey, theta 2, go this side. You are troubling me. Okay, theta 2 over. Okay. See, D, which one members you want? DC, DF and AF. Yes, 1, 2, 3. See. We can turn, no problem. Where, see. Okay, cut. X. Now, don't go there. Cutting above 3 members. Now, class. Decide which side is easier for calculation. Everybody will tell, sir, this side is better, sir. Okay. Then, okay. Look this side. So, right here. Consider equilibrium of frame, pin-jointed frame to left of XX. So, since you are looking to left of XX, A is intact. See, that VA upward, how much? 16.312. I will ask sign. Some will tell plus. No. When you write VA here, don't write sign here. You took upward. Positive came, mark same direction. Negative came, mark opposite. But don't write minus there. 16.312. Then D point also is there. See, this for AD. Then up 2 loads are here. See, 2 loads. Then little more continued here, little more continued. So this, for this, when you consider equilibrium of this way, these are all the external forces from this side. Now what you have to consider? 99% people will tell, now you consider internal forces in these 3 members. No. When you cut here, when you consider equilibrium, which side you are not considering, from that side, consider once again external forces only. This I will upload a class in YouTube to teach those people who got wrong concept. Okay, right now. See, I got so much confidence. This concept, internal, external, I cannot make mistake. Okay, so see here force. Force for towards joint D for DC. Here, see, it is not CD. It is force to at this point, forced towards joint D from DC member. See, I told outgoing. Okay, all take, see, D is to C, D to F, and then here, here A to F, see, D to C, D to F. A is here from A side to F. Now I will not tell all these things, sufficient. This is a question. So many questions are over. See here now. Now, for this PDC, angle is, you can write anywhere you want. See, space is there. See, this force, instead of wasting space there, I can write angle here, 37.875, theta 1. For this member, see, this member, DF, with horizontal, angle theta 2 is, how much? This angle is 52.125. If it is 51.5, here also 52.125 degrees. Okay. Now, over. Start. Apply the three basic equilibrium conditions. See, sigma H0, sigma V0, sigma M0. But you should always apply in the reverse order. Easy for calculation. No rule. I always first apply sigma M0. Take moment about the point where two unknowns are meeting. Oh yes, DC and DF are meeting at the joint D. Oh, joint D. So take moment about D. Why D? I told in the class. Okay, start. See, unknown first. These PDC and PDF are 0. 12 also into 0, 6 also into 0. Minus PAF into this height, 1.4539. Plus 16.312 into from here to here, that distance here. How much is 1.8639. You have to mark it somewhere. See, from here to here is D point. Okay, this is D. This distance from here up to here is 1.8639 meter. Calculated value 39 meter. 12. Go that side. 12 kilometers. This much meter. Now, therefore, if you take moment about this point, minus PAF into height 1.4539 plus 16.312 into 1.8639, it is a calculated value equal to 0. You will get PAF plus 20.973 kilometer. Then sigma V0, upward positive. See, unknown first. Now, PAF is got. Okay, unknown first. This one. Plus PDC's sine of 37.875 minus PDF sine of 52.125 minus 12 plus 16.312 equal to 0. Both unknowns are there. Equation number 1. See, y sine y cos. If somebody will ask, I will tell, don't continue my class. At this stage, engineering mechanics, after explaining thousands of times, okay, now, we won't get the answer now. Sigma H0, right side positive, the unknown first, plus PDC cos of this angle, 37.875, plus PDF cos this angle, plus PAF, plus 6 equal to 0. Remember, PAF is already known. I will use black card. I will put black tick mark. Earlier all, I used to write substituting PAF equal to plus 20.973 kilonewton. So it is not unknown. Unknowns are still PDC and PDF. Up to what level? What? Throughout the subject I should write that way? You are not studying anything? You don't want to learn? If you cannot do all those things, you tell he is not writing the calculation, not writing. Don't continue my class. Sorry. Sometimes I should be harsh. You know what is the time now? Morning 4 o'clock. It was slightly raining here. I waited till the rain to stop because I want to upload the class. My age, this leaving sleep and working, why? For your benefit. Remember, for giving knowledge to everybody. Okay, now this is known. So, second equation, in terms of what? These two, solving, you get these two answers. Okay. Now, lastly, write the result. Result here, see. Axial force in DC. DC. 23.9385 kN. Compression. No minus sign now. See, people write here, compression. Mathematical blunder. Don't do it. No sign. See, remove sign. Tension is positive for us. See, when you enter the forces jointing away from the joint, we are unknowingly taking tensile axial force as positive, negative came compression. Force for next DF, 13.156 compression. Force for AF, 20.973 kilonewton tension. This is the answer. Now, I wrote something there. See, I told everything you copy from the question 17. Then, see, also note that class, question 17, by method of joints, we got all the result here. See, which all members we require today. I saw my earlier uploaded class, took a screenshot of that particular answer sheet and entered here. Why? It is my own calculation. I have not copied somewhere. I only did it. This is the answer we got. Okay, check the answer now. DC, 23.9385. Oh, 938 you got there. 85 you got here. Okay. DF, 13.156. Yes. AF, 20.97. Then see. Yes. Right here. We got exactly the same answer we got by method of joint earlier. Not we got. I should tell I got. You should write he got. Unless you solve and get, then write I got. Otherwise write he got. Okay. This will complete first question. Okay. Now I will do one thing. Second and third, I want more space. So, this sketch I am not removing. See, I will remove this one now. I will tell you, 1 minute. See, this all I will remove now. I want more space now. See, I want more space. So, I will make a note somewhere. How much VA I got, how much. I will make a note somewhere. In a paper, I will make a note. Somewhere, rough paper, I will make all these notes, required notes there. I will look there. When I look there, it is not that looking there for solving questions. See, I never solve like this. Have you ever seen me? This is IS code, not a textbook actually. See, this type of teaching I am dead against. I will tell every lecturer who once upon a time were my students, when they come for suggestion, I will tell them, do not take notes or textbook to the class. Sir, difficult, sir. Study, understand, practice. And if you see a textbook and do this way, see, or notes, if you do this way, what student will think? This person himself is not knowing properly. What he is teaching then? He himself is not knowing. So, if you want to gain confidence there, or if you want them to follow you or respect you more, or somewhat, develop high regards towards you, come like this. I'll tell worst come worst. In a small paper, write something and keep. Okay. If doubt is there, open it, no problem. But try to avoid it. Some will tell, sir, you can do it, sir. Yes, difficult for us. Okay, if not today, tomorrow, next year, try it. So therefore, when I look there later, I am not looking answer. I am looking what all I rubbed here now. Because why? I want this space now. For the next one, little big sketch is coming. See, sketch will take a little bigger one. This much. So writing I require from here. So this I will remove. This will be there. Okay. I'll start now. Okay. Now start. Second question. I removed everything. Calculation of axial forces in members DC, FC and FG. See, if you are seriously practicing, what you should do is, this sketch, once again you have tried. Or, if that much difficulty is there, you take Xerox copy, take a printout, Xerox copy, attach that copy here. So study. Okay, I agree. Very difficult to write all this once again. But once the previous section is there, if one more section is there, confusion will come. Not for me, for you. For me, you write 100 sections there. No problem. But confusion is there. So, write the sketch once again or take Xerox copy and attach. Now see. See here. DC, this member. Then FC, where is FC? Here. This member. And FG. Oh, this member. So, cut. XX. Consider equilibrium to, see now, left side better or right side better? I think still left side is better. See, last one question is somewhere here. Somewhere there, we will see right side. Earlier, some questions, if you remember, I once solved looking left side, then again solved considering right side for practice purpose. But there is a limit for everything. Okay, cut. Consider what? Left side only. So, you are looking this side. Okay. Looking this side means all the external forces here and the external forces acting towards these joints from that side. It is external force, not internal. You cannot mix up that way. Okay, now I will not tell once again. Now you know the procedure. Okay, start. See, this time big sketch I wrote. A intact, F intact, D intact. A, F, D intact. See, 1.4539 from here up to this point. This horizontal is 1.8693. This is 3. This all you got here. See, this lecture number 17. Sorry, question number 17. Lecture number I forgot. Oh, it's here. Lecture number 14, part 5. Okay. Now, consider equilibrium to left side. Okay, now do one thing. First, before you start, see. Question mark. Why moment about F? See here. 3 unknowns are, once again I forgot to tell, see. DC, FC and FG. Okay. All assumed to be outward. This is not tension. This is outward force acting from that side. It is not axial force. But this outward force acting from this joint later becomes axial tension for the member. That is real concept. Okay, done. Now, PDC, PFC, PFG. Among the 3 unknowns, see, 2 unknowns are meeting at the point F. So, we will take moment about F. That's why I took moment about F. Clockwise positive. See here. When you take moment about F, PFG into 0, PFC into 0, even 4 also into 0, unknown PDC. Oh, PDC is inclined force. If it is inclined force, you require perpendicular. But this time, construction not required because as per the question, this itself is perpendicular. So here only you can mark what? See, here only you can mark H, our green color. Why? H is green color there to understand. Here only you can mark it as what? H. See? H. This itself. If it is not perpendicular, drop perpendicular. See, it may come something like this. Then trigonometry. So anyway, this itself is of no use for you because you require to get H, this length and this angle. Whether H is up to here or suppose it is not perpendicular, see it may come this way. Then this is H. Again use what? 3 and this one. Okay. Now, that is H. Take moment here, see. PDC into H clockwise plus 6 into this height 1.4539 minus 12 into, see, this distance is 3 minus 1.8693 plus 16.312 into 3 equal to 0. Therefore, where H is perpendicular distance from F to line of action of PDC, we will never bother. It comes and touches D. Let it touch anywhere. It is perpendicular distance. Okay, now, first class, get the value of H. Use the triangle AFD. You should write it here. I will not write what is high school class. Triangle AFD. Suppose it comes somewhere here, H this way. Say D dash, AFD dash. So what? Okay. See, sin 37.875 equal to H divided by, this is 90 degrees, hypotenuse is 3. So you get the value of H. Now substitute that H value here. You get the value of PDC. I calculated minus 23.939 kilonewton. Okay. Or class. Again, for those people who find this confusion about H, see what to do is, do not do like this. Leave it. No H here. See. In this sketch, PDC is going this way. You mark any point in its line of action wherever you want. Wherever you want. Okay. It is, see, PDC is coming this way. You can mark here or anywhere in the line. Okay. Here is better. So, this force here, if you see, this force is going this way. It has got little space here, obstructing here, horizontal component cos and some small space problem here. Okay, 12 kilonewton. Hey, please come this side. Little this side, please. Okay, wait. 12 kilonewton. You please come this side. Okay, thank you. 12 kilonewton. And then, see, vertical component. This is cos. This is sin for this PDC referring to angle 37.875. Therefore, then, see, this component, PDC cos of 37.875 into this height, 1.4539 clockwise, then PDC into sine of this angle, this component into this distance, 3 minus this distance, then remaining same, minus plus 6 into this height, minus 12 into this distance, same as last time. Substitute, you will get PDC. Okay. We will check the answer now. I will calculate. Not calculate. I got confidence. See, calculator here. Turn the calculator. Minus 23.939. Minus 23.939. Minus 23.939 kilonewton. If you are doing this way, that is not required. If you are doing that way, this is not required. Okay. Right. Oh, salt. In my class, if I write salt means not the salt, food salt, not calcium chloride. Same as last time. Same as last time. What answer last time you got? Same as last time. People know it. My offline students, they know it. When I put salt, is it eating salt? No, sir. Same as last time. Okay. Over. Now do one thing. Space problem is there. I write here. See. Sigma V equal to 0. Take upward positive. Start. See, we got the value of PDC now. Remember, PDC is known, unknown first. Plus PFC into sine of what? 52.125. If somebody wants to explain, sir, why you took sine, means right from now, do not continue my class. If you have subscribed, unsubscribe. In future, by chance, when in the YouTube you go for searches, if you see my logo, ignore it. I am not the person ideal for you to learn. Elsewhere you learn. If somebody will ask now, earlier, see, I used to always write here. This, see, using in the hundreds of times I used to write here. Cos, sine, like that. If you expect me to write each, I wrote just now what to do. If you expect me to write each and every class, I told better study somewhere else. Okay, then plus PFC of sine of how much? 52.125. Then this is not there. Minus 12 minus 4 plus 16.312 equal to 0. You already PFC. Yes, you already know the value of C. You already know you write here. Substituting what? You write here. Substituting PFC, whatever you got here, minus 23.939. Therefore, we get which one? PFC. Why you wrote PFC once again? This is PDC. Oh, sorry. Oh, okay. This is PDC. This is PFC, correct. This is PFC. This is, by mistake I put wrong answer. This is PDC. Okay. Print mistake. PDC sine 37.875. Okay. This happens, human beings. Sine 37 point. Don't tell, sir is getting confused. 875. Okay. You already know the value of PDC here. Substitute. You get the value of PFC. 1 minute. I'll calculate. Not cheating this time. I'm really calculating. See. PFC. Where is it? Or PDC. Minus 23.939. Calculator is not on. Minus 23.939 into sine of 37.875 minus 12 minus 4 plus 16.312. It will go that side. Minus came. It will become plus when it goes there. Divided by sine of 37.875. Honestly, I have done the calculation. Minus 24 point. Where is the answer there? Which one it is? PFC. 15 point. How? 1 minute. I'll check once again. PDC. Minus 23.939 into sine of 37.875. Okay, that answer is minus 12. Oh, sorry. Not minus. It's actually plus such. Calculated. Minus 23.939 into sine of 37.875. Answer is over. Minus 12 minus 4 plus 16.312 is minus. becomes positive that side, 14 point, but it is a 15 point. How? Divide by sine of 52.125. 18 point. Something wrong in the calculation. 1 minute, no problem. 4kn, okay. 12kn, 6kn. VA is 16.312, correct? 16.312 is correct, VA. Then where is wrong mistake here? 1 minute, it can't happen. Not in my class. PDC sine 37.875. Correct. PDC is correct. Plus PFC sine 52.125. Oh, see, mistake. For this member, angle is theta 3. It is not, how much? It is not 52.125. See, mistake came. It is 66.801 degrees. See sometime what happens. Small mistake. It is observation mistake. I thought second angle. It is this angle. This angle is how much? 66 point, how much I wrote it? 801 degrees. Okay, now if I do the calculation, see, sine 66.801 degrees. Okay, no problem. So whatever I got, I'll divide by sine of previous angle, sine of 66.801. I'll multiply the old value, that is sine of wrong value, 52.125. 15.650. Yes. Plus 15.650. See, I never get panic. See, that actually what happens is sometimes late, now it is early morning, 5 o'clock. So, I thought second angle, wrong angle I took. See, if I make such mistakes, I realize immediately, this is not technical mistake, this is print mistake. But if you make the mistake, how you know it? You will put the wrong value and continue the question. That's why be careful. For me, lot of checks are there. Even in statically indeterminate structures, I got plenty of checks. The moment I make any calculation mistake or print mistake, wrong data mistake, I can make out immediately. But you have got difficulty, so be careful. So see, I can, if I wanted, I could have cancelled the recording or cut the recording and hide this part. I don't hide. Everything is open from my side. Okay, start. Lastly, sigma H0, take right side positive. And now you got what? Now you got PFC also came. See here, we got even PFC also. This also came. Lastly, PFG. It is plus PFG, then plus PFC, plus PFC cos 66.801 plus PDC cos 37.875 cos 37.875 and then 1/4 plus 6. I'll write here now. Okay, PD is already known. Plus 6 equal to 0. Therefore, you know the value of PFC, you know the value of PDC here, everything is known. Therefore, you get PFG. I will really calculate. I won't cheat. I really calculate. PFC, where is PFC? 15.650 into cos of, where is the answer? Cos of 66.801, 66.801, that over plus PDC. PDC is how much? Plus 23.939 into minus 1, minus of that value into cos of, where is the answer? 37.875 plus 6. I am getting minus when it goes to that side, will become plus. When it goes to that side, will become plus. It will become 6.731 plus 6.731 kilonewton. Okay. Now, I will remove this one and write the answer here. See, if I remove last, the closing part. Okay. Space not required. See. Therefore, result, see, final result we got by method of section here, this one. Result. Therefore, axial force in the same order, DC equal to then axial force. Red color is not there, black only I will write. Axial force in FC and also axial force in, what I remember, FG. DC is here, 23.939 kilonewton. No minus sign, kilonewton, negative sign came, compression, FC is, where is it, 15.650 kilonewton came positive, tension, FG came 6.731 kilonewton, tension, positive. DC 23.939, FC 15.650, tension, 6.731 tension, FG. Yes, right here. Yes. Result is perfectly tallying with what we got earlier class number, class 331 engineering mechanics, part 5 lecture 14 question 17. I noted the answer perfectly tallying. Now the last part, that is 3. See, 3 over closing part. Yeah. Calculation of axial forces in the members. Which one they want? Where I wrote? Oh, I remember it. See, I removed everything, but I still remember. I wanted these 3. Okay. CE, EG, CE, comma, EG and BG. Don't tell me, sorry, in the question you told CE and not EG, GE and GB. Oh, what is this? You can call this member either CE or EC. This member either CG or GC, either GB or BG. Don't make issue of those things all. Okay. Now, those who are serious, you should write one more sketch here. See, one more sketch required. Very, very important. Right, one more sketch required. Then consider section XX cutting above 3 members. See here, where I am finishing now. This member means, see, it will come this way. Okay, no problem. XX. Now it is better to look which side? Not left side. See, left side means too many things are there. Now better look right side. For frame part, consider equilibrium to right of XX. Right of. Why right? I told in the class now. Okay, now, why I should, 1 minute, I will break first once. I forgot whether I have broken earlier or not. That's why I broke once. Okay, now I will solve in front of you only. See, this I will full, I will remove. All of you. No, go. All go. This I want, because now finally we want what? Axial force in CE. Then last answer, this I will remove. Then we want in what? EG. It's the last step actually. Then you want in BJ. BJ now. It is not BJ. It is BG. Okay. It is BG. Not BJ. BG. There is no J here. And BG. BG. Okay. See, if I got an electronic board, these problems are not there. I can do what? Space. There is no space problem. Big sketches I can write. But till I get the electronic board, helpless. Right now I can't afford it. Okay. Because quite expensive it is. Okay, now start. Considering right side. So, see here. B intact. I am doing in front of you only. Hinge support. HB you took right side, but HB answer came, where is answer? -9. So HB is left side. This all I told you thousands of times. 9 kilonewton. VB you took upward, you got positive 22.688. I told I am not seeing anything. I am seeing the copied answer there, which I rubbed earlier. 688 kilonewton. This is B. Okay. Then after B, little distance here, cut. See here. Then E is intact. Angle is how much? Angle is θ1. Okay. It will come this way. See. This way up to somewhere here. Okay. Up to somewhere here. This is the joint E. There a vertical downward force of 10 kilonewton and horizontal force of 5 kilonewton. This is the joint E intact. That's all. Then take a little more length and cut. See, this point we got. Then one member comes, see this angle is how much? That angle is θ1. Where is that angle θ1? 37.875 degrees. This angle is 37.875 degrees. Okay, then this angle is θ2. See, for this member. That is θ2 is 52.125. Not this way, little stiff. See, this way. I'll put, okay, now, later I'll put now, if I put a dotted line here, for this angle is 52.125 degrees. 125 degrees. Our cut reached, then see, our cut problem now, 1 minute now. I'll first show the cut here. Okay. Okay, now I can write 52.125 degrees. Yes, correct. Okay, now, a force going here of PEC, see, space problem, little space problem, PEC, a force going here of PEG, another force going here of PBG, and this height is known for you 1.4539 meter, and this 10 kilonewton load distance from this end. See, this distance is same as this distance, 1.8693 meter. 1.8693 meter. Okay. Now full space is there for me. See, start. Start here. Sigma m about 3 unknowns are there. Among the 3 unknowns, 2 unknowns are meeting here. So we will take moment about this point, about E equal to 0. Stay clockwise positive. Remember, if you take moment about E, this into 0, this into 0, this into 0, this into 0. Only this much. So, clockwise positive. Okay. Plus PBG into 1.4539 plus PBG into 1.4539. Then, see here, plus plus 9 into 1.4539 into 1.4539 minus 22.688 into 1.8693 equal to 0. Therefore, you get the value of force in BG. PBG will come in kilonewton. So, now you know PBG value. Nine into 1.4539 minus 22.688 into 1.8693. Answer is, sorry, calculator already not on. So auto switch off. Okay. 9 into 1.4539 minus 22.688 into 1.8693. Answer is negative. It will become positive that side. Divided by 1.4539. No cheating, nothing. Minus 20 plus 20.170 kilonewton. I sincerely got it. Plus 20.170 kilonewton. Okay, this is also over. Then sigma V equal to 0, take upward positive. See, this is already known for you now. Start. Plus PEC sine of this, for this fourth angle is here, sine of 37.875 minus PEG sine of 52.125 minus 10 plus 22.688 equal to 0. Both are unknowns. You get equation number 1. Okay, then, black color, equation 1. Then, sigma H equal to 0, take right side positive. Oh, all are negative. Okay. Minus, which one first? Minus PEC. Minus PEC cos of 37.875. Again minus PEG cos of 52.125 minus PBG 1, 2, 3 minus 5 minus 9 minus 5 minus 9 equal to 0. See, PBG is known for you. Whatever you got with sign substitute. So, still same unknowns. Equation number 2. This is a known value. Solving 1 and 2. You get what is PEC and what is PEG. It is getting nearing early morning now. Another half an hour, there will be sunrise. Same rain problem. Waited up to around 3 o'clock for this one, because when rain comes here, sound will come here. So, therefore I waited. See, all this for you. So, this time, feeling tired, I will do one thing. I will not cheating. It is confidence. PEC. Plus minus 34.762. See, minus 34 point. See, something fell down. It is protesting. You are not calculating and you are writing the answer. See, I don't know where it went. Pen cap. Okay, I'll search later. But without cap, the pen will not stand. Sometime what will happen is, it will become dry. That is the problem. Okay. PEC, you know? What do you want? PEC. PEC is minus 34.762. Somebody will tell, this is called cheating. Yes. 762 kilonewton. And PEG, compression, minus 10.963 kilonewton. Okay. This is not cheating. It is confidence. See, I am feeling really tired. Therefore, decided, no, you do it. high school mathematics, over. Okay, now, therefore, check the result. Force in CE, EC, 34.762 kilonewton. Negative sign came, compression, and force in EG, 10.963 kilonewton. EG is 10.963 kilonewton. That also came negative, compression, and force in BG, how much you got? BG or GB, write it here, 20.170 kilonewton positive tension. Okay, now check the answer. Some will start laughing. Sir, you copied from there and checking. No, I solved. Okay, solved. See. Yes, correct. Okay, now. P for C. C. 34.762 compression. Yes. EG. 10.963 compression. Yes. BG. 20.170. Yes. See, this is for fun. I never take the class in a stylish manner. See, I will tell you. Just information. Now, say, let's go there. Okay? See, that force into 7. I don't talk that way. This last one, yes, all fun. Teaching should be strict. See, sometimes I have seen people shouting like anything. See, no, sorry, I'm against it. They create such a scene. Someone will tell it is not teaching. It is somewhat game. It's a video. It is a entertainment video. I have seen some shouting like anything. Come on. What? Come on, you tell? Do it. Okay. Just for fun I told. Okay. It is their choice. Let them do whatever they want. I do whatever way I want. You like my class, learn from my class, I am happy. That's all. Therefore, perfectly tallying. Okay, yes, see here. Right here. Red color right here. Or yes, perfectly tallying. So, time to close the class. So, today's class also equally important. Those who are came up to here, they have gone through. Those who are not coming here, they won't listen all these things. They will treat as an entertainment class. Okay, do it. Oh, thank you. Next class we'll meet.